Hey guys, welcome back to my channel. Hope you are doing extremely well. This is your very own mask code at this side. And today is our day 31 of solving the GFG problem of the day. Okay. So before starting, there is an important update, guys, that I have created my own Discord server and I have provided the link in the description as well. So please join it before your betterment only because you can interact with your like-minded people there. And if you have any doubt, you can just comment me there, or you can comment me below in the comment box also. Also, the advantage of joining the Discord server is that we can connect of the voice channels also. Okay, so please, I think you will understand why I'm insisting you to join the Discord server. Okay, moving to the problem. So today's problem is known as Grinding Geek. It is kind of a promotion by GFG itself. So GFG has come up with a new scheme of selling the courses. That is, it is offering you a new course each day. That course offering you a new course each day, and now the offer is that if you complete it in within 90 days, if you complete it within 90 days, you will get 90% of your money as refund. Okay, a very attractive offer, and I will suggest you if you buy one. It is not a promotion as well because you know that I'm not that popular right now. So a geek like you has decided to buy as many courses as he wants, to buy as many courses as he can. Okay, so he has got some money in hand and he has got an array. Suppose the array contains 10, then 5, then 4, then 3. The array index is that this is the price of the course on day 1, day 2, day 3, day 4. Remember that the course on day 1 can be bought on day 1 only, not on any other subsequent days. Similarly, for 5, the day 2 can only be bought on day 2, not on 1 or 3 or 4. Okay, so far and so forth for both of the rest one, that is 4 and 3. Okay, now the geek decided to do the maximum number of courses. What he will do is he will buy a course, complete 90% of it on single day. That is, if he buys on day 1, he will complete 90% of it, the course on day 1 only, and then get 90% back on the same day. Okay, so that he can maximize the number of courses here he is possibly purchasing or doing. All right, now we have to tell him the answer, that how many number of courses he can do, maximum number of courses he can do. All right, this is a problem statement. I hope you're clear with the input and output. Okay, moving to the solution. How will you approach this? Okay, so many of you will think that if I got money in hand, suppose this is 10, okay, I will go back to the day, like this is day 10, the amount asked is 10. I match that I have the money required, okay. I will pay 10, I will get 9 back because 90%, so 90% of 10 is 9, pretty evident. So I just spent 1 rupee on this course, so my amount becomes 9 and my answer changes to 1 because I've done one course up till now. I move to the next course, see if it's affordable. Yes, 9 is greater than equals to 5. Again, paid 5 and get how many? Now, here comes the catch. 90% of 5 is actually 4.5, but you will only get 4 because it is written in the question statement that you will get floor value of 90%. Okay, so floor value of 4.5 is actually 4, so you will get 4 only back. So now 5 minus 4 is 1, so you just paid only 1, so 9 changes to 8 and my answer changes to 2. Okay, similarly for the fourth one, yeah, we can afford it also. So 4, I spend 4 on it and I get 3.2 as return, but it will change to 3, so I will getting 3 as return. Sorry, 3.6 as return, change back to 3, spending 1 on it again, it will change to 7, it will change to 3. All right, again spending 3 on it because 7 I have the money in hand that I can buy this course. Spend 3 on it, got 2. Why? Because 90% of 3 is 2.7, which will convert back to the floor value, that is 2. got got 2 back, spent 1 rupee only, so 6 changes to 4. pointer goes out of the index and my answer is actually 4 and I have still money in hand. Okay. But I just have to return the answer. Okay. So this was a problem statement. I hope you are clear with the input output and the scheme we are using. Okay. But there is a small catch that we cannot use this algorithm. That if it's possible, then buy it. No, not possible. Because it might be the case somewhere. Suppose the array looks something like X, Y, Z, A. Suppose the conditions for X, Y, Z change something like you buy a course for X, get reverted some say something like B, okay, and then you're not able to buy Y, Z, or A. It might be the case 90% because you are depending on the future income. How many money is getting cut from you, okay. But it might be the case that in this situation only, if you skip X, that if you don't buy it, then you can buy all these courses frequently. In that case, the answer will be 3, not 1. 3, not 1. Okay. So I think you are getting the hang of it, that you cannot move greedily. So how can you do that? How can you pursue this question? You have to use what can I say, recursion. Try all possible sequences that are possible for the given amount of money and the cost array. So it will be solved using recursions, and recursion will state that make all possible subsequences and then return the answer by checking the maximum. Okay, how will the recursion work? Let me write the pseudocode for you. The recursion would work something like, suppose my recursion is known as f, the function is f. I will take the index and the money left in my hand. Okay, if my index is greater than equals to n, what is the n here? The total size of the array, that my courses are not left with me. In that case, I will return 0 because not possible to buy any course right now. Okay, now I can either take it or not take it. The course, I'm speaking about the course. I can either take the course or not take the course. I can only take the course if my money in hand is actually greater than equals to cost of course. Okay. Now if this is true, then only take will become f of n plus 1 minus total minus cost plus total minus cost, because minus we are giving that cost plus we are getting the floor value of that cost multiplied by zero point 0.9, because we are getting 90% refund, right? If this is not true, my take will be else, take equal to 0. Okay, speaking about not take, so not take is being simple, just skip it. So what will we do? We'll go for f of n plus 1 and same amount of money we have in hand, because we have not buy anything or we have not getting any refunded. Okay, so at last we have to return the maximum, return max of take and not take. Also small modification, take will be 1 plus this. Why? Because we have just bought the course, right? So we'll increment our answer by 1. Okay, so this is our final algorithm. How will this work? Let me show you the dry run. So our array was 10, 5, 4, 3, and we had money in hand as 10. So first I will get a call. Let me mark the indexes 0, 1, 2, 3. I will get the call for 0, comma 10. I will see that it will get divided into 2 because 10 is affordable using the money 10. So 10 is affordable, so take and not take. If I take it, I'm moving to the first index using 9 money. I saw that 90% of 10 is 9, so I'm just spending 1 money on it, 1 rupee on it, and I'm getting the total money left with me is 9. F of 1, comma 9. Now it will have also two cases. Also the case here will be f of 1 comma 10, right? The case for here will be either take it or not take it, not take it. If you are taking it, second index move with 8, because 90% of 5 is actually 4.5, but it will get converted to 4 and spending only 1 rupee on it, so 2.8. Another approach is don't buy anything, move with the same money. All right. Now 2.8 will say f of 3.7 or f of 3.8, and then f of 3.7 will say f of 4.6 or f of 4.7. Okay. Now you will see that 4 is actually out of index, so it will return 0 and it will return also 0. Now it was on the take side. This will have to add 1 also here, so it will get maximum as 1. It was also on the take side, so all the left sides are 1 actually, and all the right sides are 0. So 1 is getting on the f of 3.7. Okay, 1 I got in my hand. I have to add 1 and return 1 here, return 2 here, sorry. And f of 3.8 will process two possible cases, that are f of 4 comma, what can we say, 4.7 or f of 4.8. Okay, if I bought it, I will have to add 1, so it will return 1. It will return 0. Maximum is 1, so it will return 1. Now maximum out of 2 and 1 is 2. It will return 2 plus 1, that is 3. It is returning 3. Now 2 comma 9, again the tree will continue, f of 3 comma 8 or f of 3 comma 9. Now f of 3 comma 8 is actually running 1. So you are seeing that there are cases of overlapping sub problems. And what we have learned about overlapping sub problems is that it will be a case of dynamic programming. I will include the DP into the code I have written above. Let me complete the tree first. So 3 comma 8 will return 1. Now 3 comma 9, two cases again, f of 4 comma 8 or f of 4 comma 9. It will return 0. It is 1, so it will return 1. Again 1 maximum, returning 1 here. It is returning 1, it is returning 1, so it will also return 1. Now it will have to choose from 3 and 1, so it will choose 3 and return 4 here. 4 here. Now 1 comma 10 I have to process. Two cases again, f of 2 comma 9 or f of 2 comma 10. Now as you can see, f of 2 comma 9 is actually returning 1. So I will also return 1 from here only. And 2 comma 10 is not a sub case right now, which we have rendered, so it will change to f of 3 comma 9 and f of 3 comma 10. Okay, f of 3 comma 9 is again 1, so 1 it will return. F of 3 comma handle, so f of 4 comma 9 or f of 4 comma 10. Now it will return 1 because we have bought 1, and it will return uh, sorry, it will return 0. So 1, it will return 1. It is actually returning 2 because it will be 1 here, so 2. Now 2 is maximum, so it will return 2 here. Now 2 is maximum, so it will return 2 here. But 4 is already present, so it will return 4 on the driver function. So our answer is 4. And if you checked, the answer was literally coming out to be 4. If you can see here, the answer was 4. So our answers are matching. That means our algorithm is correct. For the DP, I thought that DP will be used in the question. How we can use DP? We will just make an vector vector of type int, that is a 2D matrix of type int, name it as dp, and size will be, dimensions will be n plus 1 into total plus 1. Total means total money in hand and at starting. Initialize all of them by -1 and send them to the function. Now if, after this base condition, if dp of int total is not equals to -1, then return dp of int total. Okay, and here when we are done returning, update your dp also. Dp of int total is equals to max of take and not take. This was our algorithm. Analyzing the time complexity and the space complexity, time complexity of this algorithm would be O of n into total, that is number of days into total money, and space complexity is also same, O of n into total. Why? Because this time is required to fill up the dp array, and this time is required, this space is required to make a dp array space. Okay, so I think the algorithm was clear to you. And if you like if you're liking the algorithm, if you're able to understand, then please subscribe, please subscribe, please subscribe, because the amount of subscribers are actually very less from the people who are watching it. So I will very much appreciate if you actually subscribe. It gives me a lot of motivation, guys. Okay, moving to the code. Also, I will request again to join my Discord server. Moving to the code would work like, I will first make a dp array of type int. Size will be n plus 1 cross total plus 1, initialized by minus ones. Okay. My answer would actually be solved by a function f, and I will pass n to it, my total to it, my cost to it, my initial index is 0, and my dp array to it. And after I get answer as my answer, I will return the same answer. Okay. Now I just have to implement the answer. I just have to implement the function. Okay, so my function is returning an int. So int f, taking an int n, total money, a cost array, passed by reference, my index, and my dp array. Now, my first base condition was that if int is actually greater than equals to n, in that case, return 0. Okay. Otherwise, if dp of int total is not equals to minus 1, in that case, return dp of int total. Now, my intake is initially 0, and it will change to a good value if my cost of int is actually less than equals to my money in hand. In that case, take will become equals to 1 plus f of n. My money will change to total minus cost of that index and plus 90% of that. So floor 0.9 multiplied by cost of int, that is for 90%. This is my total cost. Now send the cost array, increment your index by 1 and send it, and at last send your dp array. Okay, this is for my take, and my not take will be simply written as solve f of n, same total, same cost. Now index will be incremented and rest of the things are same. Okay, and at last update your dp array, dp of int total equals to max of take and not take, and return it. Okay, this is our whole code. Hope it runs, running compile and run on it. Running fine for the compile and run case. Check it out for submit also. Working fine. Hope you liked it. And you can see that we have completed 31 days of a streak, so it is actually a month. And I would like to celebrate my 1 month journey on the YouTubers also. I started my journey on 15 December only, and today is 15 January. And I actually cherish the love from you guys, and thank you very much for supporting me. And please stay tuned, and if you are not subscribed, please hit the subscribe button. And if you have liked the video and if you have understood the algorithm, so please like the video and drop down a comment if you like the way of explaining. Thank you for watching. Have a nice day.